Good morning, students. Today we are going to discuss about the Zener Diode third class. In the previous two classes we discussed about the introduction about the Zener Diode, working principle of the Zener Diode and comparison of the Zener Diode with the PN junction diode we discussed in the last two classes. So now we try to discuss further about the Zener diode in this class. So now we try to discuss about the comparison between the avalanche breakdown and Zener breakdown of the Zener diode. These two are the main effects which are produces the conductive path in the depletion layer of the reverse biased Zener diode. So now we try to compare these two. So what we are comparing is basic comparison areas we are here. Avalanche breakdown and Zener breakdown we having the first definition. What is the avalanche breakdown? The avalanche breakdown is a phenomena of increasing the free electrons or electric current in semiconductor and insulating material by applying the higher voltage. If you increases the free electrons in the semiconductor, so that is called as a avalanche breakdown. Zener breakdown, the process in which the electrons are moving across the barrier from the valency band of the p-type material to the conduction band of the lightly filled n materials is known as the Zener breakdown. So the thing is, what is the meaning of Zener breakdown? The process in which the electrons are moving across the barrier from the valency band of the p-type material to the conduction band of the lightly filled n material is known as the Zener breakdown. Simply we can say is that at high voltages the minority free charge carriers collides with the collide with the stationary atoms and generates the free electron hole pair. So this type of breakdown is called as the avalanche breakdown. Zener breakdown means because of the very heavy doping by applying the small amount of the reverse bias, the covalent bonds of these ions at the depletion layer are breaking and generate the free electrons. So that is called as the Zener breakdown. So what about the depletion layer? How it is? So depletion layer in the avalanche breakdown is very wider, thick, because this is not heavily doped, lightly doped. So that's why that is a thicker. Coming to this Zener breakdown, the depletion region is very small. So junction, what makes this junction? So what happens in the avalanche breakdown? Very heavy voltages, so it breaks it destroys the junction. But in the Zener breakdown, it does not destroy. In the avalanche also, we make optimization such that it does not break the junction, but it should operate at the high voltages. Electrical field, how it is? So if the depletion layer is wider, the electrical field is weak. If the depletion layer is stronger, thicker, the electrical field is stronger. So now we try to discuss some more about this Zener breakdown and avalanche breakdown. The avalanche breakdown and Zener breakdowns are two different mechanisms by which a PN junction breaks. Already you know the avalanche breakdown and Zener breakdown are two different mechanisms by which a PN junction breaks. The Zener diode and avalanche, the Zener and avalanche breakdown both occur in diode under reverse bias. The avalanche breakdown occurs because of the ionization of electrons and hole pairs, whereas the Zener diode occurs because of the heavy doping. So you try to remember this point. The avalanche breakdown occurs because of the ionization of electrons and hole pairs, whereas the Zener diode occurs because of heavy doping, because of the heavy doping we are getting. So you can see the what it produces in the avalanche breakdown. It produces the pairs of electrons and holes. In the Zener breakdown, what happens? It breaks the covalent bonds. The covalent bonds in between the free electrons, a lightly bond, that is called as the covalent bond, lightly bond. So the bond will be breaks here because of this applied electrical field. So it generates the electrons. But in the avalanche breakdown, it generates the pairs of electrons and holes. Doping in the avalanche breakdown, doping is low, and in the Zener breakdown, the doping is heavily doped. So reverse potential, how we need to apply? So because of the less doping, we need to apply more amount of electrical field. We need to apply the high amount of reverse potential in the avalanche breakdown. So coming to the Zener breakdown, we need to apply the low amount of the reverse potential. So temperature coefficient of this avalanche is positive. Temperature coefficient of Zener diode is negative. The meaning is temperature increases, the free charge carriers increases in the avalanche. But coming to this Zener breakdown, temperature increases because it is heavily doped. It may try to get the resistance for the free electron charge carriers. Ionization. In the avalanche breakdown, because of the collision, we get the ionization. So here in the Zener breakdown, because of the electrical field only, applied electrical field only, we will get the ionization. Breakdown voltage. The breakdown voltage directly proportional to the temperature. So in the Zener breakdown, the breakdown voltage is inversely proportional to the temperature. After breakdown voltages may vary in the avalanche breakdown, but in the Zener breakdown, voltage remains constant. Now we try to see the equivalent circuit of an ideal Zener diode and actual Zener diode. Equivalent circuit of an ideal Zener diode and actual Zener diode. Ideal Zener diode, you can see how it is. Ideal means it may not having any internal resistance drop. Simply we can replace the Zener diode with a voltage source. That is, the voltage source will give a constant voltage supply from that source. It having the fixed voltage. So the ideal Zener diode replaces with the voltage source. In a circuit, an ideal Zener diode can be replaced by a voltage source Vz when the Zener diode is operating in the breakdown region. So generally the Zener diode is used in the reverse bias only. We don't use the forward bias. So that's why the representation of Zener diode, whenever we are using Zener diode in any other circuit, The functioning of the Zener diode is nothing but the reverse bias functioning. That is the reverse bias functioning. So in the reverse bias, Zener diode will be breaks at particular voltage, that is called as the Zener voltage Vz. After that, the voltage should not varies, only the current will be varies through the Zener diode. So that is represented in the ideal Zener diode. Zener diode is replaced with the voltage source Vz. That means it gives the constant voltage Vz irrespective of the supply voltage. So coming to the actual Zener diode, how it is. So actual Zener diode means any device, it does not exist without having any errors. In the universe, we don't have any perfect device without having the losses. So Zener diode also having some sort of loss, so that is indicated by internal resistance of Rz. So that amount Iz Rz amount of voltage should be dissipated or what you say elapsed from the voltage source Vz. So the voltage across the Zener diode will be the supply voltage, if you say Vz plus Iz Rz. So Iz Rz may be lost from the Zener diode because of its internal resistance. The actual Zener diode is replaced with the, that is the voltage source with some sort of voltage drop, that is the Iz Rz. So that equation also indicated, you can see V equal to Vz plus Iz Rz. The total voltage represents the amount of supply voltage applied to the Zener diode. So now we try to discuss about the application, one of the application of the Zener diode. So one of the main important application of the Zener diode is act as a voltage regulator. Zener diode as a regulator, as already we mentioned in the applications. So see the circuit diagram, how it is, we can see like this, the signal is there. So the major application of a Zener diode in the electronic circuit is a voltage regulator. It produces the constant voltage to the load from a source whose voltage may vary from 0 to 15 volts or 230 volts, we can say like that. The Zener voltage regulator provides a constant voltage to the load from a source whose voltage may vary over a sufficient range. So you can see the diagram, circuit diagram of the voltage regulator. We having the DC supply, and we are connecting the Zener diode parallel with the load RL. You can see the parallel with the load RL, and the resistance, some series resistance R is there, that is called as a current limiting resistor. We can vary the DC supply depending on the rheostat we having there. So we may having the potentiometer at the DC supply. So the total setup DC supply and this potentiometer is in the voltage, what you say, in the voltage regulator knob. Voltage supplier is there, voltage supplier will give the DC supply. So here what we need to achieve is, we need to prove that if we change the supply voltage, the output is same as the Zener voltage. If we change the load, then also the output is same as the Zener voltage. Or we can say that if you change the supply voltage, output of the Zener diode or across the voltage drop across the Zener diode is Vz. If you change the load also, the voltage across the Zener diode is same as the Vz. So this is called as the voltage regulation by both the ways, changing in the supply making the load constant, changing in the load making the supply is constant. So like this it adjusts the current such that the output voltage is constant. You can see in the above circuit the Zener diode of Zener voltage VZ is connected across the load RL in reverse condition. You can see, you need to remember that the Zener diode should be connected in the reverse bias. That is important. That's why. So what we are doing is in the above circuit the Zener diode of Zener voltage VZ is connected across the load RL in reverse condition. The constant voltage V0 equal to VZ. The constant voltage V0 equal to VZ is the desired voltage across the load. The constant voltage V0 equal to VZ is the desired voltage across the load. The output voltage fluctuation is absorbed by a series resistor R which is connected in series with the circuit. You can see the arrangement is such that if any output voltage fluctuations is there, that output voltage fluctuations are absorbed by the series resistor R which is connected in series with the circuit. By this adjustment, by this absorption, the voltage across the Zener diode must be a constant as the VZ. This maintains a constant voltage across the load V0. So that is called as a VZ. So in the above circuit, the Zener diode of Zener voltage VZ is connected across the load RL in reverse condition. The constant voltage is the desired voltage across the load, that is nothing but a Zener voltage VZ. The output voltage fluctuation is absorbed by a series resistor R which is connected in series with the circuit. This maintains a constant voltage across the load. Let a variable voltage Vin be applied across the load RL. The first condition is, now we try to vary the input voltage Vin across the load RL. What happens? When the value of Vin is less than Zener voltage VZ, when the value of Vin is less than Zener voltage VZ to the Zener diode, no current flows through it and the same voltage appearing across the load. So before occurring the Zener breakdown, what happens? The Zener diode acting as an open circuit, whatever the voltage we are applying, the same amount will be appear across the output side, because Zener diode is not in a Zener mode, not in a breakdown region. So until it reaches the breakdown, whatever the voltage we are applying to the Zener diode, that is appear across the load. So that is, when the value of the Vin, that is the supply voltage, is less than, when the value of applied voltage is less than Zener voltage VZ to the Zener diode, no current flows through the Zener diode, and no current flowing means it is an open circuit, and the same voltage appear across the load, same voltage appear across the load, that is the load voltage is nothing but the applied voltage. Next, the Zener diode, after reaching the Zener diode conducts a large current is when the input voltage is more than the Zener voltage. What happens? When the applied voltage is more than the Zener voltage, the Zener diode goes into the breakdown region then the Zener diode conducts a large current. Then the Zener diode conducts a large current is when the input voltage is more than the Zener voltage. As a result, large amount of current flows through the series resistor R, which increases the voltage drop across it. What happens? Large amount of current is flowing through the diode means the diode is seriously connected with the series resistor R. Large amount of current is flowing through this means what happens? A large amount of voltage drop occurs across the series resistor. As a result, large amount of current flows through series resistor R, which increases the voltage drop across it. Thus, the input voltage excess of Vz. What amount of the excess of Vz is absorbed by the series resistor. So this is the adjustment of the series resistor and Zener diode. The amount of excess voltage than the Vz is absorbed by the series resistor, that is Vin minus Vz. That difference is dropped across the series resistor. Hence, a constant output voltage Vz is maintained across the load resistor. This is the first condition when the applied voltage is changes. How the Zener diode maintains the constant voltage across the load. The simple thing is what happens, that series resistor absorbs the excess amount of the voltage and it will give the constant voltage across the Zener diode. The next one is the second condition is when a Zener diode of the Zener voltage Vz is connected in reverse direction parallel to the load, it maintains a constant voltage across the load equal to the Vz and hence stabilizes the output voltage. So what it says that when a Zener diode of Zener voltage Vz is connected in reverse direction parallel to the load, it maintains a constant voltage across the load equal to the Zener voltage and hence the stabilizes the output voltages. So like this it will stabilize the output voltage. So another one also is there, if the applied voltage is constant and load is changes, what happens? If whenever we applied the Zener voltage, we fix it as some constant voltage and we make the Zener voltage Vz. If the load is changes, what happens? When the load changes, what happens? If the load having the less resistance, what happens? Large amount of current is drawn through the load. If load having the high resistance, large amount of the current is flowing through the Zener diode. In both the ways, the resistor absorbs the excess amount of the voltage at the series resistor such that the voltage across the load will be constant. So that like that the Zener diode of Zener voltage is connected in reverse direction parallel to the load. It maintains a constant voltage. Across the load equal to the Vz and hence it stabilizes the output voltage of the load. That's why the Zener diode is called as a voltage stabilizer or voltage regulator. voltage regulator. This is the main application of the Zener diode. Some other applications also is there, but we having the discussion of elaborately about the Zener diode as a voltage regulator. Now we are entering into the last topic of the Zener diode. So we try to discuss about the Zener diode ratings. What are the important factors about the Zener diode? Zener diode ratings. The first we try to discuss what is the rating. So first we try to discuss about the rating. What are the ratings? The word rating means the various information about that particular device is given on the nameplate of the device or data sheet provided by the manufacturer is called as a ratings. So in general, if you wanted to buy any device and any electronic component, we try to see what are the features are there, what are the different things are there. We try to see. So those type of values are given on a data sheet or on the nameplate. So that is called as a device ratings. If we know the ratings, then only we choose our application what type of ratings are matches and which rating device will give the perfect outcome to our device. The word rating means the various information about that particular device is given on the nameplate of the device or data sheet provided by the manufacturer is called as a diode rating. This data sheet, what it shows? This data sheet shows the rating of different diodes, which include ratings of different diodes, which includes Zener voltage. What is the Zener voltage of the diode? Tolerance range. What is the tolerance range of the diode of a Zener voltage? Zener current limits and maximum power dissipation, maximum operating temperature, maximum Zener resistance or impedances, etc. If we know these things only, we can do the experiment perfectly. Otherwise without knowing ratings, if you take the device, if you use the device, what happens means it cannot meet our application, our required applications. So what this diode rating data sheet gives, that this data sheet shows the rating of different diodes, which include Zener voltage, the tolerance range of Zener voltage. What is the tolerance range? Zener current limits, the maximum power dissipation, maximum operating temperature, maximum Zener resistance or impedances. So like this, these will give the values. Now we try to discuss what are these terms in detail. We try to understand these terms definitions and what are the ranges we get in the market. We try to discuss. The first one is Zener voltage. It is a VZ we can indicate. The voltage at which a Zener diode breaks in the reverse bias condition known as the Zener voltage. As we will know, that is a voltage at which Zener diode breaks in the reverse bias condition known as a Zener voltage. Each diode having its own Zener voltage. Each diode having its own Zener voltage. So that is different Zener diodes are there. Zener diode is having Zener voltage ratings from 3 volts to the 200 volts. Zener diode is having Zener voltage ratings from 3 volts to the 200 volts. The Zener diode having Zener voltage ratings from 3 volts to the 200 volts. So what it means that the Zener diodes are available in the range of 3 volts to the 200 volts, 300 volts breakdown diodes. So in the small voltage drops given by the Zener breakdown device, Zener breakdown Zener diodes, and in the large voltages are because of the avalanche breakdown. So this is called as a Zener voltage. This voltage value should be indicated compulsorily on the data sheet. By this only we can say that this device having the this much amount of Zener breakdown voltage. The voltage at which a Zener diode breaks in the reverse bias condition known as the Zener voltage. Zener diode is having Zener voltage ratings from 3 volts to the 200 volts. Tolerance of Zener diode. So what is the meaning of tolerance? Tolerance is nothing but for any device it may having some plus or minus addition and subtractions are there. We can't get the exact value between the particular range of the values. We will get the value that is called as the tolerance. You see the definition of the tolerance how it is. The range of voltages about the breakdown voltage in which a Zener diode conducts in the reverse direction is called tolerance. We say that 7 volt is a Zener breakdown voltage. We can say like this: 7 volt is the Zener voltage breakdown voltage, but practically we may have 7.5 or we may have 6.5 voltage. So this range 6.25 to 7.5 is called as a tolerance of particular Zener diode. The range of voltages about the breakdown voltage. The range of voltages about the breakdown voltage in which a Zener diode conducts in the reverse direction is called tolerance. Is called the tolerance. For example, you can say consider a particular type of Zener diode marked as a 9 volts. Zener diode is marked as 9 volts Zener voltage and 10% tolerance. What it means? In 9 voltage 10% are plus or minus. So in this range also consider as a 9 volts. These Zener diodes may have a breakdown voltage from, you can see 10% of 9 volts means 0.9, that is 8.1 minus, that is 9 minus 0.9, 8.1 volts to 9.9, that is 0.9 instead of exactly 9 volt for all. So this is called as the tolerance of the Zener diode. We should also know this tolerance. Why? Because we taken as a 9 volts, but we having the range between the 8.1 to 9.9 volts. So our application also should be like that only. The application should accept the 8.1 volts. It should withstand with the 9.9 volts. It should allow the minimum value and it should withstand with the maximum value. Then only our application will give the actual correct values. Consider a particular type of Zeners marked as 9 volts, 10% tolerance. These Zener diodes may have a breakdown voltage from 8.1 volts to the 9.9 volts instead of exactly 9 volts for all. So the how we are getting this range means the 10% tolerance means it may either additive or subtractive. In this range, you may take it as a you may grantedly you may take as a 9 volts for all these values. So exact temperature of on a Zener diode. So this is another effect. Another is the effect of temperature on Zener diode. This is also a very important factor. If the Zener diode is used in the temperative environment, whether the temperature may having any effect on the Zener diode, we should know. So that value is given by this effect of temperature on Zener diode. You see here the breakdown voltage of the Zener diode depends upon operating temperature. Compulsorily in the semiconductor, the operating voltage should be depends on the temperature, because if the temperature is increases, what happens, the free charge carriers are generated in the semiconductor. That is the reason the breakdown voltage of the Zener diode depends upon operating temperature. It decreases with the increase in the junction temperature. What happens? Zener breakdown voltage is decreases if the temperature is increases. Why? Because temperature increases, the free charge carriers minority or majority it may increases, so that it may reduce the Zener voltage value. This is because of the increased reverse current that is increasing in minority carriers that flows within increasing temperature. The decreases is about 10 megavolts per degree centigrade rise in the temperature, millivolts per degree centigrade. So what happened means, for degree centigrade increasing, 2 millivolts of the breakdown voltage is decreases. So because this is because of the increased reverse current that is increased in the minority carriers that flows within increasing temperature. The decrease is about 2 millivolts for degree centigrade rise in the temperature. For degree centigrade rise in the temperature, 2 millivolts should be decreases from the as actually mentioned Zener voltage, that is a VZ. So another important one is the power ratings. Another important one is the power ratings of Zener diode. So the power rating also very important regarding the devices. So what it indicates that how much of power we can apply to that device. For example, if anything is there, it is a weak, and we try to give more and more on that, what happens, it may strained, at the last it may damage, it may collapse. So the same thing, we need to know how much of power should we apply to this Zener diode. So what is the maximum range amount of power we need to apply to this particular device? Otherwise, if you apply the excessive amount of the power supply, what happens, the device may short circuited, or may damaged, or may goes into the burning stage, may burns itself. So that is the case, that is the importance of the power ratings of a Zener diode. It is indicated by, you can see, PZM, Zener diode maximum power rating. So what it theoretically represents is here the maximum power which Zener diode can dissipate without any damage is known as its power rating. So you can also see the maximum amount of power dissipation across the Zener diode. So the maximum amount of the power which can the device withstand is known as the power rating. The maximum power which Zener diode can dissipate without any damage is known as its power rating. Commercially available Zener diodes have power ratings from 1 by 4th watt, that is a 0.25 watt, to more than 50 watt. Until 50 watt we can use as a Zener diode. This is a thing. Commercially available Zener diodes have power ratings from 0.25 watts to the more than 50 watts we can apply. The power rating is the product of maximum current through the Zener diode which a Zener diode can handle and the rated or operating voltage of the Zener diode. Already we know the Zener diode voltage Vz, but we need to find the maximum current of the Zener diode which can handle or rated current which can pass through the Zener diode, which will give the power rating of the Zener diode. That is the Pz maximum equal to Iz maximum and Zener voltage. Iz means the Zener diode maximum current. Pz means the maximum power which can withstand by the Zener diode. The power rating is the product of maximum current Iz maximum with a Zener diode can handle and the rated or operating voltage of a Zener diode Vz is given by the power rating of the Zener diode. The next one is the maximum current ratings, so which we need to know. So what is the maximum amount of current passing through the Zener diode? We also know that amount, otherwise it may damages the device. So the maximum value of the current which a Zener diode can handle at its rated voltage without damage is known as its maximum current rating. So generally it is from the power rating we can get. The maximum value of current, which a Zener diode can handle, at its rated voltage without damage is known as its maximum current rating. By using this maximum current rating we can measure the maximum power rating also. So all these parameters are given in the data sheet. Diode rating, you can say specifications of the device. So it gives the total values of the particular device. Then we can choose which device is more suitable to our application. The last one is the Zener resistance or Zener impedance. How much of this diode having the internal resistance? How much of it having the resistance? The opposition offered to the current flowing through the Zener diode in the operating region is known as Zener resistance or Zener impedance. We can say Z. The opposition offered to the current flowing through the Zener diode. As already we know that any device having some sort of opposition to the current flow is there. Even though conductor also having some sort of opposition, that opposition is called as a resistance. We having the Zener diode. This is a combination of p-type and n-type material is there. It compulsorily had some sort of the opposition to the Zener to the current flow. The opposition offered to the current flowing through the Zener diode in the operating region is known as Zener resistance or Zener impedance. It indicated as Zener resistance means RZ, or Zener impedance means ZZ. indicate what the impedance indicate that some amount of AC resistance may have, so that is indicated by the impedance. When a Zener diode is operated in the breakdown region, an increases in current produces a slight increase in the voltage. You know that we can show that as we are increasing the current, it produces some sort of increasing in the voltage. This shows that a Zener diode has a small AC resistance called as Zener resistance or Zener impedance. So this also we should know how much it is varying when we are connected in the reverse bias. So that we can get the a perfect suitable device to our applications. So these are the main things we need to know about the Zener diode. The first thing we need to know is the Zener voltage. After knowing the Zener voltage, we need to have the tolerance of the Zener diode. We need to know the Zener voltage, then we need to know the tolerance of the Zener diode, and what is the effect of the temperature on the Zener diode, and what is the power rating of the Zener diode, and also we know about the maximum current rating and what amount of the Zener resistance is offered by the Zener diode, so that we can choose the perfectly suitable Zener diode for our application without having any errors. So this is about the Zener diode. So we complete here Zener diode comparison between the breakdowns of the avalanche breakdown and Zener breakdown, and also we discussed about the Zener diode ratings in detail. Thank you.